Hello everybody, my name is Apurva and today I am going to be showing you how do vaccines work. So what does a vaccine even do? Well, everybody probably knows what a vaccine is. Basically this shot that makes you pretty much immune to whatever disease is meant for. Correct? So a vaccine, okay, horrible illustration of a vaccine. But I think most of my viewers know how a vaccine looks. Okay, let me draw a better drawing of a vaccine. It's basically a syringe with some liquid that is injected into the skin. Okay, and then it basically prevents you from getting certain illnesses, or at least makes you not sick. So it kind of helps. So how does a vaccine exactly work? Well, to understand that, first we must understand how the immune system works. So let's see how will a vaccine work. In this case, I'm going to be taking a bacteria. Virus will be pretty similar as well. I'm pretty sure. Let me just go through. So here is a bacteria infection. Now, say you've been infected by food, or say it was a cut and there's some type of new bacteria there, and your body has never seen this bacteria before. Now, when this invasion happens, first of all, nothing is noticed much at first, like when there's only one bacteria. But then they start duplicating and more start forming. And as more start forming, then your body starts realizing something's wrong because they are using up your body's resources to duplicate. And therefore, the cells nearby are getting harmed, and then your body gets alerted, and that's when the immune system kicks in. So now there are these huge cells called macrophages, pretty big. So what they do is they find bacteria and then swallow them up inside a shell. Okay, so then these bacteria cannot do anything when they are inside the macrophage. They're not dead, but they are covered in a shell. Oh, my black is slightly thinner. I just realized that. Okay, never mind. So they're trapped inside the shell. So now that they're trapped inside the shell, then what happens is there will be these enzymes which will come and attach to the cell and give off and which will kill the bacteria. These enzymes then come here at the shell and destroy the bacteria. So these macrophages can eat up loads of bacteria. Like this, just like nom 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 nom. And there are many of them, and then so many come and start eating up. But say that's not enough. So the bacteria are still reproducing and getting worse. Then there are these cells called neutrophils, which basically, with the macrophages, call onto the battlefield. And neutrophils are very violent, extremely violent. So they're not that big, and they basically what they do is they fire toxins everywhere. They blast toxins everywhere next to them. They blast toxins like crazy. They're on a mad toxin blasting streak. Okay, and these cells commit suicide after a few days, otherwise they cause too much damage to the body itself because of they are very violent cells. Like they do mass destruction. But if this is still not enough, then there's a cell known as the dendritic cell, which comes into play. Okay? And so what the dendritic cell does, okay, you know what, let me use a different color. I'll get confused. You know, let me just undo. Yeah. So they say this is the dendritic cell, and now what the dendritic cell does is it eats up the bacteria, but it just eats up one. Instead of completely destroying it, what it does is it rips it apart and displays the bacteria antigens on its surface. The bacteria antigens, they are all on the surface. So every bacteria has the antigens which are allowed to bind and stuff, steal resources, do other things. Those antigens are very useful. Allow chemicals from the outside to react. So the dendritic cell displays those same antigens on its surface. Human cells have their own antigens. This one is right now displaying the bacteria antigens. So now what does the dendritic cell do? Well, it will now travel through the lymph nodes and arrive at a lymph node. Where there will be these cells known as T cells, which will be inactive right now. They're just sitting there doing nothing. They're doing nothing. And there are a few types of T cells. Helper T cells are one, and then there are killer T cells. So, see, instead of a bacteria invasion, if this was a viral invasion, which is usually what happens, a viral invasion is also very possible. The dendritic cell will alert helper T cells, but it will also alert killer T cells. And I will come to what's the difference in them in a moment. So the dendritic cell will try to find the correct helper T cell which will match to these bacteria antigens. So each T cell's antigens are slightly different than the others. So it will keep doing trial and error, and there are several of these dendritic cells. I don't know how many. There could be thousands of them. Testing all of the T cells of different types inside the lymph node. Test until one binds. Then instead of becoming inactive, it becomes an active one. And once it's active, what happens is it starts duplicating. Okay, some become memory T cells. Okay, some become memory T cells, while some become memory T cells, while the others helper T cells go out on the battle, and some go to the B cell part where all the B cells are in the lymph node. Now the B cells. Now let me change my color. See, let's make them green. Yeah. So the B cells now in the lymph node. So now some of the T cells, helper T cells have come here. Now the killer T cells, as I was getting to, if it was a viral invasion, viruses latch onto cells' antigens, get inside and infect them. And once the cell becomes infected, basically it hijacks its DNA, makes it make more viruses inside, as viruses cannot reproduce on its own like this bacteria can. And so then what happens is the viruses then burst out of the cell, and the cell releases millions of viruses from that one virus that infected it. That cell just basically dies. Okay. But what happens sometimes is that replication process takes some time, and then some enzymes are created which destroy the cell and all the viruses rupture out. So the killer T cell job is to basically destroy any cell that has been infected before it erupts and lets out a hell ton of bacteria. So basically, it kills other cells that are infected in a viral invasion. But for a bacterial invasion, they are not necessary. So those killer T cells, if it is a viral invasion, would be going around the body searching for infected cells. There can be immune cells as well that could be infected. And so it goes around teeter-tottering, figuring it out. Then when these guys arrive at the B cells, they're all of these inactive B cells. Okay, wait, not all of them are big, I realize. Make them all the biggest size. Yeah. In case that's why some of them are small and some like red is big, yellow is also a bit small. Anyway, so these T cells go to the B cells and they try to find the matching thing that matches the T cells antigens. That's their goal. So when they find the correct one, the B cell gets activated and not a dormant cell, and it starts replicating madly that same type. Even the type that matches the dendritic cell replicates like mad, and only that specific type because that is the current type that's useful. All the others are not, and I'll tell you why in a moment. So now this B cell, which is a specifically activated one, will replicate itself, not the other ones. Those ones won't. Those will just stay dormant. These ones will be active. Some will become memory, which will store this, and I'll explain what the memories do, both of them in a moment. So what happens is these B cells then start making antibodies of that same antigen type. So B cells have that bacteria antigen, so they make antibodies that fit to that. And so the B cells start producing things. Now let's go back to the battlefield. In the battlefield, things are getting bad. The good guys are kind of losing. Helper T cells are also there in the battlefield to continue stimulating the attacking cells currently, so that they don't die of it. So it keeps telling like the helper T cells are kind of like those cheerleading guys who are like, come on, you can do it, you can do it, you can do it. Okay, they aren't really fighters. Okay, and the killer T cells are just going around murdering cells if it's a viral invasion. Okay, which is what happens when the coronavirus is there. SARS-CoV-2 or COVID-19, whatever name. Anyway, so if it's a bacterial invasion, there won't be any killer T cells. But anyways, but now these B cells come and arrive and they start firing millions of antibodies everywhere. So basically what they do is they bind to these bacteria Okay, let me draw the antibodies in a different color. So they bind to the bacteria, all these tiny antibodies. They're really small, and they kind of clip on all of these antigens, rendering them useless. And especially for viruses, antibodies are very useful because the virus needs the antigen to needs its antigens to enter cells and replicate. So if the antibodies have come and completely wrapped its antigens, it can't go inside any cells. So it renders these cells completely useless, whether virus or bacteria. All of them rendered useless. And then these macrophages can eat them up with ease. They can't really do anything, they're immobilized. They are now completely useless with the antibodies. And our cells gobble them all up, and we win in the end, most times at least. This is what happens usually. Now, sometimes the body loses because either the body does not react enough, does not have enough immune cells, and cannot figure it out. So that's why sometimes it doesn't. But most times, with a healthy immune system, many viruses are eradicated. Now, what were those memory cells for that were left behind? And all cells commit suicide basically after the battle, so not to miss anything. But the memory T cells and the memory B cells will remain behind, and those will remember that same virus. So if it were to come again, the dendritic cell would immediately know, go to the memory cells, immediately give it to the memory cell. The memory T cell would go to the B cell, and it would be very quick. And instead of taking a long process of that trial and error where you have to find the correct one, it will happen a lot quicker. Okay, so this is how your immune system works. Okay, and now what does a vaccine do? Basically, like I said, with memory cells, the process happens a lot quicker. So the vaccine job is to avoid the hassle for the very first time before the virus even reaches you, to completely avoid the hassle of doing this trial and error. Therefore, because while that trial and error is happening, macrophages can't continuously eat. Even neutrophils will start damaging cells, and actually they cannot usually fight it off on its own. That's why we want to get the antibodies, which are the most overpowered defense. And for viruses, macrophages and stuff are powerful, but they usually get infected. And so that's why it's very important to have the memory cells. And the killer T cells only get activated when the correct match is found, right? So that's why the killer T cells will only get activated there. So that is the major problem with a virus. That it can, by the time your body finds stuff, you could be ill, you could be sick in the hospital, as many have from COVID-19. Well, the virus's name is SARS-CoV-2 to be specific. So now, what does a vaccine do? Well, a vaccine is basically a weak or dead form of that particular virus that you're trying to stop, virus/bacteria. So a weak form of that, basically. What's a weak form? So they will probably give a weak COVID-19 or something like that, or something that has just the antigens and stuff. So it's basically something that makes it look like a threat because it's something that the cells don't recognize. Like all of our cells have antigens that make sure that other cells don't think it's an enemy. But the immune cells, which are constantly floating around, quickly detect that it is an enemy. They very quickly detect what's an enemy or not. So they detect that dead virus or antigens or stuff are some bad thing, and they start attacking those peacefully and stuff. And we inject lots of them, so they think that there's a battle going on. Neutrophils try to fire, but they're already dead. And the body doesn't know that. It starts doing all the attacking and stuff. And then the dendritic cells arrive. Then they take the antigens and go to the T cells. And after a couple of days, the memory cells form, and all of those dead bodies are eradicated. Okay, but the body doesn't realize that they're dead, obviously, and that's why you don't get any side effects. Sometimes there are side effects because the vaccine wasn't properly made, so it actually depends, and that's why they are testing vaccines such that it helps the person and does not cause other problems, which is the hard part. And once you do that, what happens is those memory cells are created. So the next time you really get the virus, you won't fall that ill at all because the memory T cells will be quickly activated, and then your body will fight it off like it will have an advantage basically. So the first time a body gets a virus, it does not have an advantage. It needs to figure it out. The second time the body already knows, So it's basically like if there's a new type of Lego set, for example, say you got a new Lego set, okay, and you have the instructions, you still have to figure out the instructions a bit because it's a new set. You need to figure out where it goes where. But say you have already built that Lego set before, and another that same Lego set comes, and then your the instruction booklet is there, and you already know how to use it. Actually, a better example would be you don't have an instruction booklet for a Lego set. You have to figure out everything. You just have to figure out what the final result will be. But say you notate it down, and that's what the memory T cells are for. If you don't, then again the second time you'll again have to refigure it out. Okay. So then when the memory cells are kind of like that booklet, so you write down all the steps that you figured out. So the next time you can just build it very easily. That's basically the point of a vaccine, is to help your body get in an upper hand. So basically the body already has the method of fighting the virus. Basically the correct antibodies to fire are ready at disposal for the body without having to do it the first time. And since they are dead viruses, it is not a real threat, meaning those things cannot actually attack you. But if you want to, that's why vaccines are never the real virus, because what the heck is the point then? Then everybody will have to get infected, which is useless. That's why you need a vaccine which basically makes you pretty immune, basically immune to death, and you won't have severe symptoms at all. Practically no symptoms from it. So that basically is why a vaccine was made. So this is a video on how vaccines are made. And this is also about how the immune system works briefly, that is. So thank you guys for watching. Please subscribe to my channel. Don't forget to like this video and turn on the notification bell so you don't miss out any new content. Bye!